Hello everyone, this is Dr. G. Karthik Reddy, working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. Today's session topic is characteristic function, and today's contents is definition of characteristic function and importance of characteristic function, the properties of characteristic function, problems on characteristic function, and the relationship between characteristic function and probability density function, and definition of characteristic function. Characteristic function is defined for any random variable. Random variable may be anything, either it may be the uniform distribution or Poisson or Gaussian or Rayleigh or exponential or binomial. It may be any random variable, and it is denoted by phi x of omega. It is denoted by phi x of omega. X represents the random variable, omega represents just variable. And the definition tells that which is equal to expectation. E represents the expectation of exponential to the power of j omega x. Here j represents imaginary operator. J represents imaginary operator. Now here the definition for a continuous random variable. This is the definition for continuous random variable. Here the x lies between minus infinity to infinity. X lies between minus infinity to infinity. This definition, expectation of some function. How we can write that? Expectation of some function. Here function may be g of x. Where g of x is equal to e power j omega x. Then what is the definition? Which is equal to integral minus infinity to infinity g of x into fx of x dx. Here small fx of x represents probability density function. This is a case for continuous random variable. Here j is the imaginary operator which is equal to the square root of minus 1, and here omega is a real number which lies between minus infinity to infinity. We are also having the relation how the characteristic function is a Fourier transform with a negative sign of density function. This part we will discuss in the properties. Now next, along with that, you are having this is for continuous random variable. For discrete random variable also you can give the summation I equal to 1 to n g of xi fx of x, here instead of fx of x, p of xi. This is a case for discrete random variable. This is a case for discrete random variable, and this is a case for continuous random variable. These two are the definitions of characteristic function for both discrete and continuous case. Now next, we will discuss some of the properties of the characteristic function. First, you have to be clarity about the definition of characteristic function. Phi x of omega, which is equal to expectation of e power j omega x. J omega x. This is the definition. Here, what you are having in place of x, for example, you consider the characteristic function of a scale random variable. You consider this as y. Then phi x of phi y of omega is equal to expectation of e power j omega y. Here in place of y, what you are having? Expectation of e power j omega y. In place of y, a into x plus b. You split this one, what you are going to get? Expectation of e power j omega ax into e power j omega b. E power j omega b is a constant. Take outside that e power j omega b. Here expectation of e power j omega ax. You can also further rearrange that e power j omega b, expectation of e power whatever you are having ax. What you are going to get for this phi ax of omega. Here you are having rearrange the terms in terms of at you can take. Then what you are having? Then e power it plus instead of it you are having j. jtb phi x of whatever you are having at you are going to get. Just rearrange the terms. You are going to get that term. Now this is one of the property. Now next you are having one more property. What is the major advantage of characteristic function? Characteristic function, by using characteristic function you can easily calculate up to nth order movement about mean, movement about nth order movement about origin. nth order moment about origin. We already discussed that about the order of the moments. If you are having n equal to 1, you will get the expectation, n equal to 2, you will get the mean square value. Similarly, we can also calculate for up to nth order of the nth order movements. Nth order movements we can calculate. These are all used for identifying the characteristic behavior of any function. Okay, any function we can identify. Now here nth order movement. Okay, by using single expression we can able to calculate the up to nth order movements. For example, if you are considering n equal to 1, if you are considering n equal to 1, expectation of x d by dt phi x of t at t equal to 0. Okay, first what we have to do, we have to calculate the characteristic function. Phi x of t equal to expectation of e power j omega x. Okay, then what you have to go for the expansion of that. What is e power j omega x? 1 plus j, okay, 1 plus omega x by 1 factorial, omega square x square by 2 factorial, omega x power omega power 3 x power 3 by 3 factorial, so on. Okay, then what you have to do, you have to differentiate it. When you differentiate the first term, only this part is left and remaining part will be 0, and then what you are going to get the remaining part, and you substitute that, then you are going to get the coefficient of that represents the expectation of x. Similarly, second order movement, the coefficient is called mean square value. Okay, that is the same definition is telling, it is obtained by differentiating the characteristic function n times with respect to t at t equal to 0. Okay, when you substitute, okay, for to get the second order movement n equal to 2, you have to do double differentiation of characteristic function and equate t equal to 0. And next, third one, characteristic function is continuous and uniformly bounded. Okay, uniformly bounded. You can check it the definition. Phi x of omega equal to exponential to the power of e power j omega x. Okay, if you are taking the omega t, okay, you are having the phi x of, okay, 0. Okay, when you substitute 0, then exponential of e power j 0. Okay, then it is 1. Then you are going to get, okay, expectation of 1 you are going to get. It is always bounded between less than or equal to 1. Okay, and uniformly bounded. Okay, minimum value is -1 to 1, you are going to get these values. Now next, it is symmetry property. Symmetry property, what you are going to get? Okay, the symmetry property tells that phi x of minus t is equal to, okay, this is the real, okay, this is a complex conjugate of phi x of t. Okay, this is the property, one of the property of characteristic function. Now next, independent property. You can also use the independent property. If x1 and x2 are two independent random variables, then the characteristic function of their sum is a product of their individual characteristic function. That is, phi x1 plus x2 of t equal to phi x1 of t into phi x2 of t. You can check it that expectation of e power j omega, in place of y is equal to, you consider x1 plus x2, then here you will get x1 plus x2 of t. Then what you are having, you split this one, expectation to the power of e power j omega x1 t into e power j omega x2 of t. Okay, then you split this one, again you will get the phi x1 of t into phi x2 of t. Okay, this is the one of the property of the characteristic function. Now, by using the definition of characteristic function, you can calculate the, okay, different distribution function. Okay, how to calculate that? Okay, normal, exponential, uniform, all are the continuous random variable. Then what is the definition? Phi x of omega or phi x of t. Okay, here phi x of t, you are considering phi x of t equal to integral minus infinity to infinity e power j x dx into phi x of x dx. Okay, here you know the definition of normal distribution of density, normal distribution for the density of phi x of t, exponential density function and uniform density function. You have to substitute and you have to simplify that. Then you will get the final expression for normal distribution, exponential distribution and uniform distribution. Okay, these are the formulas we are having for when you substitute the different values of fx of x in characteristic function. If you simplify it, you will get the, these are the formulas for the normal, normal, or we can also call other name is called Gaussian distribution, exponential, and this is for uniform one. Now we'll discuss one problem, like we have discussed that exponential distribution function. Okay, we are going to calculate this one. How you got this one? Okay, just substitute phi x of t or phi x of omega is equal integration minus infinity to t. This is the x value lies fx of x dx. We know that density function of exponential phi x of x is equal to lambda into e power minus lambda x, where lambda is greater than or equal to 0. This is the graphical representation of exponential, okay, exponential density function. Now you simplify it further. Okay, here just substitute fx of x expression. Here it is always lies between 0 to infinity. Take lambda outside, then you take the common of x. Okay, then you integrate it. You know the integration of e power kx or e power ax. Okay, e power kx by k. Okay, now you substitute that, then you substitute the limits 0 to infinity, then you will get the resultant answer for phi x of omega of exponential distribution function. Now what is the relationship between characteristic function and probability density function? Okay, characteristic function and probability density function. Okay, for example, they may give in the exam point of view the problem related to, they'll give the known given value of density function. They'll ask them to calculate the characteristic function. Then it may be the density function they may give in the exam point of view. It may be either uniform, or okay, it may be either any form, okay, uniform or Gaussian or exponential, or next, okay, you can have the Poisson, you may have binomial. Okay, these are some of the example, or it may be any other function they may give, and they'll ask to calculate the characteristic function of that particular random variable. Similarly, they will give the characteristic function and they'll ask to calculate the density function. Okay, here characteristic function and the density function both form a Fourier transform pair, but here you are having in the Fourier transform pair you are having the negative sign, here you should have positive sign. Okay, only the sign difference, but the relation is same. Okay, it can also satisfy the inverse Fourier transform. Okay, generally you know the Fourier transform formula, it must be, okay, here integration minus infinity e power minus j. Okay, generally you are having minus into tx, here only the sign difference, remaining part is same. It is satisfying the Fourier transform except the sign change. Okay, finally we can conclude that we are having the characteristic function. What is the advantage? Major advantages of characteristic function is, characteristic function is defined for up to nth order movement about origin. Means by using single expression we can calculate up to nth order movements, and characteristic function and the density function form a Fourier transform pair. Okay, actual definition of Fourier transform pair, in this relation you are having only the sign change of the exponential, remaining part is same. Thank you.